am Mrs. P. Jyoti, MTech, working as an assistant professor in EC department in Sri Kasari Institute of Engineering and Technology, Nandamur. So today I want to discuss about the timers and counters of 8051 microcontrollers. Timers, counters of 8051 microcontroller. So first of all, you have to understand what is the difference between timer and counter. So timer means we can program the time delay by using the timers. Counter means we can program 8051 as a counter for counting the external events. So there are actually there are two timers in 8051. Two timers. Timer 0 and timer 1. So these two timers are 16-bit timers. 16-bit timers. So these two timer resistors, let me discuss about the timer 0. So timer 0 is a 16-bit resistor, 0 to 15. We can say it as lower byte and higher byte, named as TL0, TL, TH0. So 0 to 7 bits, that is the lower byte. Lower byte is termed as TL0 and higher byte is termed as TH0. So it is same just like timer 0, timer 1 also a 16-bit resistor. This resistor also can be divided into two parts, that is TL1 0 to 7 bits, TL1, TH1 8th bit to 15. It is a higher byte and lower byte. These two timers we can load the required 16-bit number into these timers. Two resistors are there, timer control resistors. Timer control resistors. So what is timer control resistors? So we can control these two resistors by the timer control resistors. There are two timer control resistors, T mod, T-con. So T mod means timer mode resistor. Timer mode resistor. So what is timer mode resistor? What is the function of timer mode resistor? So we can set the mode, any one of the mode out of the 4 modes. We can set the timer as the required mode. So T-con. T-con means timer control resistor. So we can by using this T-con resistor, timers, any one of the timer can be run, or flags, some flags will be there. The flags will be set or reset depending on the overflow of the timer resistor or counter resistor. So let me discuss about the T mod. So T mod is an 8-bit resistor. An 8-bit resistor. It is an 8-bit resistor. Lower 4 bits belongs to timer 0 to 8. Higher 4 bits belongs to timer 1. Higher 4 bits belongs to timer timer 1. Sorry, 7. 0 to 7. So timer 1 register MSB bit describes gate. Next bit counter or timer. Next 2 bits defines the mode, in which mode you want to operate. The programmer can program the timers by using this T mode register. Say, just like timer 1 bits, timer 0 bits will be repeated. This is the gate and this is C by D bar, M1, M0. The same designations, but these are for timer 0 and these are for timer 1. Gate. This suppose the gate signal is equal to 0. The gate signal is 0. Defines a software control. If G is equal to 1, it is a hardware control, that is interrupt control. Interrupt control. C by T bar, that is counter timer. If a counter timer bit is equal to 1, C by T bar is equal to 1. The timer 1 operates in the counter mode. If C by T bar is equal to 0 as a timer. Next 2 bits, these 2 bits M1 and M0 defines the mode of operation. Mode of operation. There are 4 modes. If M1 M0 is equal to 0 0, that is mode 0. If the bits are 0 1, mode 1. If the bits are 1 0, mode 2. 1 1, mode 3. So these 4 modes. In mode 0, the function of mode 0 is the timer works as 13-bit register. 13-bit timer. If you set these 2 bits 0 0, the timer works as a 13-bit timer. So remaining 5 bits are prescaler. Here 16-bit timer. If the bits are 1 0, auto reload. Auto reload. If the bits are 1, auto reload means the higher, see here timer registers, the higher lower byte, whatever we load in the lower byte, that will be automatically reloaded in TH, higher byte. So it is called auto reload mode. If the bits are 1 1, mode 0, the timer will be operated in mode 3. In mode 3, in this mode, it is called split mode. Split mode. In this split mode, timer works as a 2 8-bit timers or counters. So next we have to discuss about the T-COM register. T-COM. So this T-COM also an 8-bit register. An 8-bit register. So in this one some flags will be there. Some bits can be programmed by the programmer. The first bit TF1. It is the timer 1 overflow. Timer 1 overflow. Next bit TR1. Timer 1 run. Next bit TF0. Timer 0 overflow. Timer 0 run. Next bit timer 0 run. Next bit interrupt enable 1. Interrupt enable 0. Interrupt type IT1, IT0. So this overflow resistor TF1, if the timer 1 resistor is counting is completed, then the flag will be set. It is a flag. Timer 1 overflow flag. We call it as timer 1 overflow flag. The programmer can run by using timer. The programmer can run a timer 1 by using this bit, by setting this bit TR1. This is timer 1 run. Next, the same whatever these two bits describes about the timer 1, and next two bits timer 0, and this is the interrupt enable. Interrupt enable. If the interrupt is enabled, then this flag will be set. This is for timer 1, and next bit is for timer 0. This defines timer interrupt type. Timer interrupt type. For timer 1, this is the timer 0 interrupt type. In the next session, we can calculate the time delay for the given program. Thank you.